What up, investors? What is going on, guys? It's been a while. What's going on, everyone? What's up? What's up? What's up? Today is going to be the FSHD Society webinar, live webinar, where they're going to be talking about the optical genome mapping for FSHD detection. Oh, no. So, I cannot hear this lady.
Hello, can you hear me?
Oh, good.
Good, okay. Good morning, welcome everybody. It's great to see so many people at today's FSHD Society research webinar. I see that people are still coming into the room, so I will give everyone maybe another 1 or 2 minutes before we start today's presentation.
Is it better now?
Okay, very good. I think we will begin. So I'm going to this section. Good morning. Welcome to the FSHD Society's research webinar. Today's topic is optical genome mapping for FSHD detection by Dr. Jeroen Depreeuw at Leuven in Belgium. And this, he's a molecular geneticist, and we'll learn more about him in his talk. This presentation was sponsored by Bionano Genomics. It is presented here by the FSHD Society for educational purposes. So I need to say that the mention of any products or services in any of our presentations is for educational purposes only. It does not imply any kind of endorsement. So with that, I will start Dr. presentation. I'm sorry, I've seen that the sound is not coming through, so that's really stop share. Share with sound. Let's see.
Now, guys, good. It's really strange. She's not saying anything right now.
I'm sorry, can someone in the chat tell me how to share screen? Bottom left corner, okay. Oh, sure, that's happening. All right, got that. So now I can find. Let's try this again.
Hello everybody, my name is Jeroen Depreeuw. I'm working at the University Hospital of Leuven, and I will give a presentation about Bionano Optical Genome Mapping and southern blot analysis for FSHD detection. So most of you already are quite familiar with FSHD. So it's an autosomal dominant disorder. It occurs in 4 to 10 in 100,000 cases, and so the genetic disorder. So it's a genetic disorder where you have an D4Z4 repeat with a size of 3.3 kb. That is located in the subtelomeric region of 4q35. And so in people with the disorder, you have a reduction in the D4Z4 repeat to 10 to 40 kb, so it's less than 10 repeats, while actually people that are healthy have up to 40 to 350 kb size. So normal people have really a very, very large size of the D4Z4, the number of repeats. One of the issues with FSHD is, or the genetic part, is that you have about 98% identical region that is located in 10q26, and so this region is not associated with FSHD. Also, additionally, there are two haplotypes, the 4qa and the 4qb, and among these, it's only the 4qa that's actually that causes FSHD, and so located in proximity of the D4Z4 repeat is a DUX4, and this is actually overexpressed in FSHD patients. And this protein is involved in, is a transcription factor involved in RNA metabolism, stem cell, and germline development. Noteworthy is also that you have FSHD2, and so this is compromised about 5% of the FSHD patients, and this is not due to a reduction in the D4Z4 region, but it's actually the SMCHD1 that is mutated, and this protein is actually involved in epigenetic silencing of the D4Z4 repeat. But to have D4Z4 or to have FSHD2, you also need to have a 4qa haplotype. So this is actually a very good overview. So in healthy patients, you have a closed chromatin and with a number of repeats of D4Z4 from 11 to 100, while actually when you have the 4qb haplotype, there's no stable messenger RNA because you don't have a poly A tail in the RNA. So therefore, when you have a reduction but have the 4qb haplotype, the messenger RNA is degraded, and then you have no DUX4 expression. While on the other hand, if you have 4qa haplotype and also the reduction to 1 to 10 repeats, then you will have the stable messenger RNA, and so you have the expression of DUX4. So as I told already, so FSHD2, that's when you have a mutation in SMCHD1, and therefore you don't have the methylation of the DUX4 repeats, and then you still have the expression of the stable messenger RNA, and then this results in DUX4 protein expression. So normally the detection method to detect FSHD is with the southern blot. So with this you do an EcoR1 or BLN and in combination with BLN1 digestion. So you have a probe, a radioactive probe, that's the P13E11 probe, and so it binds to a region in proximity of the DUX4 repeats. And then in the 4q35, you have the, so you don't have the BLN1 restriction sites, so you know that you have a reduction in the size for the EcoR1 bond on the southern blot. While actually when you have the 10q26, you will have also the restriction with BLN1, so therefore there's only one bond visible. But now we are also investigating Bionano. And so Bionano, it's actually a technique that's with optical genome mapping. So it's an instrument that uses high molecular weight DNA, and then it linearizes the DNA with, and it also has certain fluorescent labels. And so you load this this mixture on a chip, and then then it goes through nano channels, and it gets linearized, and then you can actually visualize the DNA strings. So here you have a movie that's where actually the DNA goes through the micro channels like this. So here you see one DNA string, and the molecules can be more than 200 kb. So you have the backbone that's stained in blue, and then you have certain probes at specific restriction sites that are colored as green. So when you go through the protocol, so you first start with an so you can use blood or cells, tissues, or other samples, but we mainly use fresh blood. Then we do an high molecular weight DNA extraction method. It is with a magnetic disk. After this DNA extraction, we do labeling that with specific sequences that are across the entire genome. Then we load it on a chip. And we run it on the Sapphire, and then with this, all DNA strengths are getting linearized, imaged, and labeled, and there you have specific barcodes through the entire genome, and then you can actually align this similar as you do next generation sequencing, and with this you can eventually detect whether there is a certain insertion or other variations. So you can actually detect deletions, repeat expansions, translocations, insertions, tandem duplications, inversions, and so on. But so for us, we mainly work with DUX4 repeats. So it's more a specific method to also detect FSHD. So if you go through the entire workflow of Bionano, so you have actually 3 days that you need to work in the lab. So it's the first day is the DNA extraction. So we start from blood, and we do a white blood cell purification. But the advantage is that it can be stored at -80 degrees, and you can store it there probably more than 1 year. But you need to freeze it within 4 days from draw date. So then you do the DNA isolation. You homogenize all the DNA. After this, so you have the high molecular weight DNA that you can actually store at 4 degrees for long term. And in a second day, that takes about 6 hours. You start with the DNA quantification, and after this, you do a DNA staining. And then the last day, you do the DNA quantification, and you load this on a chip, and this only takes about 2 hours. Also, after the DNA staining, you can also keep the stained DNA about 1 or 2 weeks, or even 1 month, although the quality gets a bit less, but it's actually possible also to have a stopping point here. So, and this is for us, it's quite useful that we can store the DNA, and we can actually play a bit around when we will do the DNA extraction or the DNA staining and so on. When we compare the Bionano with the Southern blot, our Southern blot protocol, it takes more weeks. I think it's about two or even sometimes 3 weeks. So you have to do a DNA extraction, restriction, the electrophoresis, the transfer, also the hybridization with the radioactive probe, which is also a disadvantage because you have radioactive waste then you do the washing and the detection. And also here we don't always have a very straightforward result. So the interpretation of a Southern blot is very difficult. Additionally, we use up to 10 micrograms of DNA, so we need a lot of blood. Most of the time we require up to 10 ml of DNA. But actually, when we go to Bionano, there you can do 6 patients at a time, but it only takes 3 days, and in total it's about 1 week if you take into account a few stopping points. Another advantage is that you need only 750 nanograms, so it's up to 1 or 2 ml. Maybe keep 1 additional vial as a backup. So this is actually an example of a chip that's running. So there you can see the number of DNAs per scan and also the mapping rate. So you can, during a run, you can monitor how the chip is going, and you have some quality parameters that you can follow during the run. When the chip is actually done, you just take, you can just select a sample. You click on the generate and focus FSHD analysis, and then it automatically generates an FSHD analysis. It takes about 4 to 5 hours for a sample, depending on your throughput target, but it generally takes about 4 hours. And after this, you get a PDF report where you have the entire FSHD analysis in one very clear report. So this is an example of the report. So you first have some quality parameters, then you have a table with the number of repeats and the haplotype. Additionally, you can have a look at the molecules that are mapped to the specific haplotype. So this is for the for chromosome 4, and then you also get some additional information. So in more detail, you can see the sex of the sample, the molecule quality, some stable regions, whether the quality assessment is performed well, and then also the haplotype and the count with the corresponding coverage. And also important is that you can have a look at the copy number of SMCHD1. So this could be interesting because the copy number variation in this region might cause FSHD2. So here you have the different haplotypes. So here you can clearly see. So this is actually the barcode for QA. This for 4QB. Then you have the number of repeats, and it automatically calculates how many repeats are found within this for this patient. So at our hospital, we started around November 2020, and then so we started with 3 samples, but now we're really ramping up. We're hoping to do about 10 on average each month. So in total, we have now 48 samples. We have quite a backlog of 34 samples that are waiting, and we have actually around 10 patients each month that are coming. So also very interesting for us is that we also have so we work in close collaboration with hematological oncology, and so they have very urgent samples with a very short turnaround time, and they also use Bionano, but the wet lab protocol is completely the same. And so because we always want to do 6 samples at once, we have when they have an urgent samples, we can take the samples with us, or when we have an urgent sample, they or need to fill up until having 6 samples. They use samples from us. So this is actually very interesting for us that we can closely collaborate, because the wet lab part is the same. It's only at the end where you need to do the analysis. Instead of clicking do an FSHD analysis, you just press the de novo pipeline. And then, so the results of these 48 samples, so I just made a box plot of the number of repeats of the 4QA and the 4QB allele. And as you can see, you really have very long number of repeats. So when you look at the size, it's up to more than 300 KB. So it's very good that we see such a large number of repeats, because with the southern blot we were not able to detect these bonds. So we are still writing the validation process, but we hope to finish this quite soon. And there we did a comparison between the genotype of the southern blot and also the genotype of Bionano. And so for all the samples that we did, so these are about I think 13 unique samples, we had 100% concordance. So all the samples that were normal with the blot were also normal with Bionano, and even it was very sensitive. So we didn't have any issues or negative results with Bionano. And additionally, because we weren't able to discriminate between the 4QA and the 4QB, we also observed one sample that was borderline, but this was actually the 4QB haplotype. So this is quite important for the patient. Also, when we look at specificity and sensitivity, we didn't have any false negatives or false positives. So this sensitivity and specificity was 100%. Also looking at the reproducibility, so we did so 4 people are now can perform the Bionano, and we didn't saw any difference in the number of repeats between these lab technicians. So it shows good reproducibility, also in terms of repeatability. So when we repeat one sample within one run, we had exactly the same number of repeats. Also, when we look at the throughput target, I think so that's actually the number of DNA that you run through the flow cell. So you can choose. The only disadvantage is the higher the throughput target, the longer the chip has to run, and also the more analysis or the computational time will be more. And so from the Bionano guidelines, you have the de novo assembly, where it's suggested to have a throughput target of 320, and then there you have a coverage of 70. Also for FSHD, you can have about 400, and there the coverage is about 70. Although there are variant analysis, so this is to detect really structural variations that are about 5% of the allelic fraction. There you have a higher throughput target of 1,400 with higher coverage. And so here we confirmed that based on an in silico analysis that for us, for FSHD, the difference between the 400 or the 480 and the 1,400 throughput target was for us the same. So we are now using the 480 as a cutoff because 70x coverage is sufficient to have the correct or as a sufficient coverage. So as a conclusion is that we are now using Bionano as a powerful technique for FSHD1 testing. So we have a high precision, high sensitivity, specificity, reproducibility, repeatability, and a high robustness, with the additional advantage that you have low input material, so you only need 1 ml of blood. You can store it at minus 80 degrees. You have a result in 3 to 5 days. You can discriminate between the 4QA and 4QB haplotype. You also can detect structural variations in proximity over the T4Z4 region and SMCHD1. The analysis and the result interpretation is very straightforward and easy. Additionally, that we are now investigating a bit into more detail, is that we might detect other STRs, and we can also, when the report is negative, but the patient has some myotonic phenotype, or myopathy, then you can also look for other structural CMVs or structural variation in the entire genome. And maybe in a later phase, which will be, or stage with the methylation stage, could be very, very interesting, because then we can really monitor how well the D4Z4 region is actually methylated. But this is, I think there is only one paper published about this, so it's that's not yet possible now, but this might be possible in the future. A disadvantage, though, is that we are only working with 6 to 10 samples per batch, and because we have such a big backlog of samples, and we might be interested in detecting other STRs, it would be good if we could do more samples at the same time. And so this is also something for a slide from the Bionano Symposium. So there are some STRs like Fragile X that could be detected also at our lab. We first do a PCR, and then when we see that the patient has an expanded STR, we then do a Southern blot. But now we're thinking to skip the Southern blot and then just do, if you have an expansion, go directly to Bionano. Then lastly, I would like to thank my team, especially Valerie, Steven, and Jolien, because they were working very hard with me to have all these results and give me some feedback. Also the group of Barbara de Waal, so she's working with the hematological cancers, and Wendy, and Professor Joris Vermeers and his group for helping me with the Bionano. So this was my presentation. I hope you enjoyed it, and if you have any questions, let me just ask.
Wow, that's very nice.
Thank you very much. Let's put our videos back on. Thank you for this really great presentation. Everybody in the audience, if you would like to ask questions, I recommend using the Q&A, or you can raise your hand and we can unmute you. So I see a question from Dr. Alexander Bellew. There are cases of multiple D4Z4 arrays on the same chromosome, each with different size. Can you detect these?
Could you please specify what you mean with multiple D4Z4 arrays? Is it then that you have just a duplication of the entire region, or is it with a 4QA, or what exactly is this related to?
Let me see if I can unmute Dr. Bellew. There you go. Dr. Bellew, you're allowed to talk now if you'd like to.
Hi, okay. Can you hear me?
Yes. Yeah.
Okay, fine. So June, very nice to see you. I missed you at the FSHD Society meeting. Nice to see you. Okay.
Thank you.
Jeroen, you might not know, but the DUX4 gene was discovered when I was in the team of Desiree Cullen at the KU Leuven.
Okay.
So my question is the following: we are in a subtelomeric region with many strange rearrangements occurring on the chromosome, and so patients have been identified that have one D4Z4 repeat array of, let's say, 6 or 7 units, which is located a few kb or 10 kb away from another D4Z4 repeat array, which has like 30 units. So that by working on a southern blot, the large repeat array was detected, and the conclusion was that those individuals did not have a genetic FSHD. And it's only by working on a DNA combing method that using a stretch of DNA, hybridizing with different probes, you were able to detect that there were 2 D4Z4 repeat arrays, one of which was very short and allowed for the expression of the DUX4 gene.
Yeah, okay. It's an interesting question. So I think it depends also on how the mapping of the D4Z4 array actually is. So if you have the 4QA or the 4QB, that's already that should be already quite some probes that will align this region. But additionally, of course, it depends also, and that actually I don't know. So maybe it's a good question to ask for the company. But so if you have on the 5 accent and if you have there some of the if you have there sufficient probes to map the molecules, then of course I think it will be detected as some kind of mosaicism in the test. But yeah, it's a very good question. But for the details, I think it will be good to ask at the companies.
Yeah, so I think it would be very interesting if you could compare your data with the ones that are obtained with DNA combing by the group located in Marseille, because this is a major advantage of their technology as compared to Southern blot. You don't have to slice your DNA in pieces and then try to reconstitute the puzzle. You work on the single DNA, and what I understood of your technology, you also work on a strand of DNA. You don't cut your DNA into pieces in your Bionano system. So
no,
you should
indeed,
be able to have the same advantage as they have.
Yeah. I think it's indeed. It would be very interesting, but because we only have results from Southern blots previously, so we don't have the data yet to investigate it. But it would be definitely very interesting.
I can send you the reference if you want.
Yeah. Okay. Thanks.
Sure. Thank you. Thank you very much, June.
Great, thank you. And Alexander, I missed the chocolates you used to bring from Belgium to our conference. Question from Maggie Williams. Is there a specific DNA extraction protocol required?
Yes, so we also investigated this. So Bionano has its own DNA extraction protocol, so it's based on the magnetic disk. But we also investigated some other methods, like an agarose-based method from another company, and also 2 kits from QIAGEN. And so one from QIAGEN was MagAttract, I think, and the other one was the gene. I don't know by heart, but it was. But so we compared the 4. And although we didn't have a pulse field shell electrophoresis to really identify the exact size, so we were a bit limited on the technology to estimate the size, but we saw that that based on the method that we had, that the Bionano protocol really had the largest size of the molecules. So I think. Therefore also because we are a diagnostics lab and we really want to have the entire protocol from A to Z from one company. So also that was a bit of a decision where we used the Bionano DNA extraction protocol. but I think it indeed could be possible to use the kit from QIAGEN. But although, because also for other disorders, I think it's the size is more important to really detect very large structural variations or CMVs, and so there I think it really matters to have the largest DNA fragments as possible, and it might be less for FSHD, but we don't know it exactly. And also because we were also doing, or at least a research team from the KU Leuven, they are also doing nanopore sequencing, and they even used the chips from Bionano, or the magnetic disk from Bionano to do a sequencing method. So it's a bit more labor intensive compared to the QIAGEN kit, but I also think the results are better. So yeah, it's a bit what you want. So yeah.
Thank you so much. Another question from Maggie Williams. Have you tried looking at any mosaic patients or patients with complex hybrid fragments?
Yes, so I think we don't have samples yet to detect mosaicism, although because also you have in hematological cancers you can detect in theory fragment or CMVs of 5% of the frequency. So in theory it should be possible. They also claim it in their manual that you could detect mosaicism. But yeah, we didn't investigate this into more detail.
Thank you. So I had a question since, are you offering this test right now? Are you doing it purely on a research basis, or is it being offered or going to be offered to patients for clinical diagnostic testing through your lab?
Yes, so I work in the diagnostics lab, so we don't do any research regarding FSHD. So, and because we really had quite some issues with the southern blot, it's really a step forward to use Bionano. So I think we are in the final stage of the validation plan, and normally within 1 or 2 months, all the patients will get their diagnostic report with the Bionano. So yeah, so it's definitely going to be a diagnostic test at our hospital.
Oh, that's great. And are there geographic or national restrictions on what patients can send samples to you, or do they have to be in Brussels or in EU, or can it be from anywhere as long as they are able to collect the sample in the proper way?
Yeah, it's so I think definitely so in Belgium we don't make really any I think it's most of the time most tests are done when so every hospital has its own tests, and when they see, or they won't put any effort in really going into a lot of detail validation if they see that another hospital also has this test. So it definitely happens that some patients from another city from Belgium will be sent to our hospital. In Europe, I actually don't know exactly how it goes because I'm not really quite familiar with the entire process, so I cannot, or I'm not really 100% sure to answer these questions.
Okay. Yeah. Thank you. Thanks so much. There's a question.
Yeah, but and also maybe also the problem now is that I think we definitely want to be a reference lab in Belgium, or at least maybe in more countries in Europe. But the problem now is that we are very limited in the number of tests that we can do. So for now, we only can do 6 or 10 samples each time. And if it would be more, if it could be 20 or 30, like really the high throughput next generation sequencing, it would be a lot better. So,
Question from Maggie Williams. Are you able to give an idea of test costs compared with Southern blot?
Yeah, I think it's more expensive, but on the other hand, you could say that our results are better. So we put less effort, less manpower into it. But in the cost, I think for us it's about 400 euros each sample. But yeah, it depends a bit. I think it's around 400.
But you can't really leave out the manpower costs. That might be quite significant.
Yeah, and so therefore it would be great if we could do more samples. So if we could do the same amount of samples as a Southern blot, it would be terrific.
This may apply more again to people who don't have access to any kind of FSHD testing in their countries. So there's interest in finding, whether there are ways of getting sufficient, good enough DNA samples without requiring the freezing. It makes it much more complicated to ship. It's doable, but are you looking at or thinking about seeing if there are other methods of DNA extraction and storage that would make it more accessible for people without requiring the -80 degrees?
I think because we now do mainly samples from Belgium, and you can still store the blood 4 days at 4 degrees. So I think for us now it's sufficient to have to do it like this. But indeed, it's a good point. We also have old data with interesting Southern blot results. So there we have the DNA. So it would be, actually it's just a matter of time and money to just put an old sample also on a Bionano chip and then see what comes out.
Very good. Again, for everyone, if you would like to ask a question, post it in the Q&A. I'm also looking at the chat. People are posting some questions there as well. So let's see. Just for me, I was just curious when you said that you can sometimes also run cancer samples on the same chip, that the wet lab process is identical. This is just for my clarification. I thought that for FSHD or for each disease situation, you might need to use specialized probes, but is that?
Yes, so the probes, these are restriction proteins, but so the restriction protein is, or the restriction site is a very specific site defined by Bionano. So I think it's 6 nucleotides, and they really have a very specific probe. But it's also possible, maybe in the future, to have additional probes with other labels and so on. So that's also what I said about the methylation-specific part. So it could be possible to really have a methylation-specific probe. But now, because we are a diagnostic lab, so we don't investigate this into more detail. But so we are happy with the probes from Bionano, and these probes are designed to bind over the entire genome and then have sufficient probes that can bind, so you can do the mapping. And so it's actually, you can compare it a bit. It's similar as you do a next generation sequencing. You have the entire genome that you can have that you sequence, but you actually only do the mapping to at specific regions of the genome. So it's only the in silico analysis. So you have the probes bind everywhere, but you don't do any capture or something. It's really you only do the analysis specific at FSHD region or at the D4Z4 region. So that's also the reason why it goes faster, the in silico analysis for FSHD compared to when you do a cancer sample.
There's a question from Alexander Belayu asking if you can tell us what your hybridization probes are. What are you using?
Yes, so it's the restriction enzymes. I think it's a bit, yeah, as I told during the other question. So it's a restriction enzyme with Bionano specified restriction sites.
Alexander, was that enough? Or did you have more specific information you're looking for?
No, that's okay, that's okay. I guess he cannot say more, but I want to be precise. So it's not restriction enzyme, it's restriction sites that you want to mention. It's a piece of DNA.
Yes, so I think it's a modified, it's indeed a restriction site, but it's an enzyme that's not cutting the DNA, of course, because you don't want to have any long fragments. So yeah.
So
but indeed, yeah, that's correct.
You are using an enzyme, you incubate your DNA with an enzyme. I had understood that you were taking a hybridization probe, so a piece of DNA that is fluorescent and will come and stick to your DNA to be analyzed.
Yeah, that's a good question. So I think that's at least how I think of it. It's that it's a restriction enzyme, but it doesn't do the restriction anymore. But it's indeed possible that it's also just a protein that specifically binds to the restriction sites that they mentioned. So,
it's very mysterious, but maybe
yeah,
it's
I think,
secret.
yeah, I think maybe the company itself can answer it, but for me, it's
yes. We have Sven Botland from Bionano who was making a
it's also.
I thought I'd give him a chance to speak.
Hey,
Dr. Sven.
Can you hear me okay?
Yes.
Dr. Sven.
Yeah, I didn't mean to jump in, but so yeah, there's no secret. So our technology uses a single enzymatic reaction that adds a fluorophore all throughout the genome. There's about 500,000 label sites in the genome, and as Jeroen explained, it's a whole genome labeling method. So for FSHD, the software will just only analyze or mostly analyze the D4Z4 region. But with that, you still get structural variation data all throughout the genome. So if there are other variants, they can also still be analyzed afterwards. And so that's why also cancer samples are analyzed with the exact same method. So no restriction. It's really a 6 base pair sequence motif, CTT AAG, that occurs about 500,000 times in a haploid genome that's being labeled.
Right.
Okay, that's clear.
Dr.
Thank
Sven
you.
is a genius, man.
I'm sorry.
Thank you. Here's a question we get asked a lot from patients because there are many out there who were diagnosed with the southern blot maybe 10, 20, even 20 years ago. And they are wondering, is there any advantage or benefit to getting retested? Is there new information or more precise information that can be gained from the new technology?
Yeah, I think, but at our lab we had a lot of difficulties with 4QA, 4QB testing. So indeed, I think for patients that had a reduction, it indeed could be interesting to investigate whether it is the 4QA or the 4QB, although there are some labs that also can discriminate between those with specific restriction enzymes, but we can't. So it's a very good point.
Actually, we hear from time to time from patients or individuals who were seen by an FSHD expert clinician. They said, "We are sure you have FSHD from your phenotype," but they were negative on both FSHD1 through, I think, southern blot testing and FSHD2, between SMCHD1 mutations. would it be interesting for you or anyone else, using the optical genome mapping to look at those individuals? Because it says it seems like there are cases you mentioned of a false negative.
Yeah, I don't know how detailed these certain blood results are, but yeah, for us, because we saw some difficulties at the interpretation of the results, we really switched to Bionano because at least you have a straightforward result. But as I mentioned, I think for these patients, definitely if you could detect the methylation status of the D4Z4 repeats, then you really go, then even if you have a mutation in another methylation enzyme, that might also be responsible for the methylation. I think this is really this could be a huge benefit for the detection of FSHD.
I'm seeing a question from Cyprien Dulac. I'm going to ask him to talk so that he can ask his question.
No, actually, it was not a question. Sorry, it was just to help with the marking of the enzyme when we discussed how the enzyme was actually labeling the DNA. So sorry about that.
Oh, okay.
But Sven already answered the question properly. Thank you.
Okay. All right. Is there any other questions? Now is your chance to ask. You can raise your hand or type it in the Q&A. No, I think, okay. Then if you have other questions afterwards, feel free to email us and we'll forward them. But for today, then thank you so much for this great presentation. Thank you to our audience for your interest. And we'll be doing more of these FSHD research webinars from time to time. So keep an eye on your email and have a great day. Thank you. Bye-bye.
Thank you. Bye.
Bye.
Bye-bye. Choose. What's up, guys? What's going on, guys? I mean, that was amazing. This guy was dropping bombs. He was literally telling us what they have been up to. These kind of things, you cannot find them. The kind of information that this guy was sharing with us, you can't find them in any news. There is no news, there's no press release, about what this guy was talking about, guys. That was amazing. I need to record a video because I was making a note. I need to record a video, talking about everything that I have managed to write down. And guys, this is a major breaking news, okay? It's a major breaking news. So I just need to, we have to. So I promise you guys to give you a talk. But first of all, let me know if you can hear me, guys. Let me know if you can hear me in the comment section, please. Let me know. If you can hear me, please let me know in the comment section. Let me know if you can hear me in the comment section. I want to give you guys a talk. Then I'm going to end this live stream because I want to record a video about what I just heard. This guy dropped a lot of bombs. I need to connect the dots for you guys, okay? I have to connect the dots for you guys. Let me know if you can hear me in the comment section so that I can give you a stock that I am watching. Yesterday, Intelia went up 50%. I have been buying Intelia since it was way below $10 US. Yesterday, it went up 50% in one day. So, right now, I think Intelia is trading around $135 US. I've been buying it. Intelia was my second stock. If you guys go to my channel, if you go way back on my channel, you can find a video that I made in January telling you guys about Intelia. The title says My Secret Stock. Okay, so Intelia went up 50% yesterday, but Intelia is not alone. I want to share a stock with you guys. So in case you want to, if you have a, of course you have to do your own due diligence. This is not financial advice, But if you have any extra fund left and you don't know where to put it, you guys should take a look at this stock, okay? I could be talking about a lot of stocks on my channel, but you know, most of you guys are just interested in Bionano Genomics. Majority of my viewers on this channel just want to learn about Bionano Genomics. That's why I created another channel where I can talk about every other stocks, okay? Because I am invested in more than 30 stocks that are doing very well right now, not only Bionano Genomics. So the name of the stock I'm going to give you guys that I want you to take a look at is, because right now, in my opinion, it is, you know, undervalued in comparison with Intelia, okay? The Intelia ticker is NTLA. So this stock I'm going to give you guys, ladies and gentlemen, is one and only Editas with the ticker EDIT. Editas. You guys should go and check it out. Editas Medicine Inc. You guys should go and check it out. I mean, not only Editas, I have another stock that I am watching in this same category. Right now, Editas is trading at $45. Few weeks ago, when, you know, most of all these biotechnology stocks were at all-time high, I think at the beginning of January, Editas was trading at $100. Then it went down to $31. So right now, it is heading back up. Now, it's trading at $45.5. So if you have any, you know, left over, you may want to start, you know, a position in Editas, because Intelia used to trade at this level, okay? Intelia used to be at the same price, you know, for months, for weeks, it was trading at this level. But, you know, I was averaging down, you know, adding to my position. I made a lot of profit from Intelia, and I still have several positions open with Intelia, you know, and right now my positions are up over 100%, because yesterday the stock price was, you know, more than 50% up, okay? So not to let me even show you guys, let me show you guys Editas, not just to be using my mouth. It's been a long time since I did live streaming. That's why I need to let me show you guys let me show you Editas. Right now, Bionano is down about 2%. This is Editas, guys. This right here is Editas, okay? With the ticker EDIT, the market cap is $3 billion right now. The volume is not really, you know, crazy. And as you guys can see, Intelia, NTLA, market cap right now is $9.2 billion. But believe me, when I found Intelia was trading around this level. I will show you guys. I will show you guys. Intelia used to be my favorite stock after Tesla until I discovered Bionano Genomics, okay? It's just happened that, you know, Bionano Genomics has a lot of retail traders around it. You know, it has a lot of, how should I even put it? You know, awareness. There are a lot of awareness, you know, retail traders creating different kind of awareness. That's, of course, one of the reasons why you guys are watching my video right now, because of Bionano Genomics. But believe me, Intelia is another beast, okay? This is the stock, you know, the chart of Intelia. As you guys can see, it went up 50% yesterday, breaking out of this massive, it was consolidating for months. Since January, it has been consolidating. Then yesterday, we saw it broke out yesterday, okay? My average is somewhere around this level. Somewhere around this level, that's where my average is. And I have been following Intelia since last year. You guys can see Intelia was trading at one point. Look at this, 2020, at one point below $10 in 2020. You know, I've been following this stock for I think since 2019 or 18 or so. That's when I've been following Intelia. I started to follow it closely since 2019. I made a video about the fundamental analysis of Intelia, and of course, it got about 500 and something views. You know, most people are just interested in popular stocks, Bionano Genomics, for example, and so on and so forth. So this is Intelia. Let me quickly show you guys the chart of Editas. So that you guys can see where, I mean, this company, they are more or less into the same thing. Of course, Intelia has much more upper hand whenever you talk about CRISPR, whenever you talk about Cas9 gene editing, okay? Intelia is a gene editing technology company. So this is Editas. Editas is more or less, you know, like Intelia, you know, more or less a gene editing company. They create their own method, okay? Intelia is using Cas9. I believe Editas is using Edit 100 or something like that. That's the name of their their own technology. As you guys can see, Editas was consolidating for years before that massive breakout in January. So you should expect any moment from now. I mean, this is just the beginning, just like Bionano Genomics. You guys can see Editas is also heading back to that all-time high. So that's the talk that I would like to give you guys as promised from the beginning of this video. So I think that's where we're going to end this live stream. So I'm gonna record a video. There are tons of information that Dr. Jeroen Depreeuw, oh my god, I don't know how to pronounce his name. He dropped a lot of bombs about Bionano Genomics, and I'm going to share it with you guys in the next video. So guys, I am going to leave for now. Victor, thanks. Victor Lopez, what's going on, guys? What's up? And I saw somebody talking about some people gossiping about me on another live stream on Charles Lock picking, talking about. I'm not gonna comment on that. And iLanky18, what's up? What's going on, guys? If you have any question, please drop it. In 5 minutes, I am going to end this live stream. As you guys know, I'm starting to record, quality. I want to be sharing quality information with you guys, not just, sending tons of videos your ways. I've tried different methods to see what my viewers want and what is, of course, good for me as well, because I cannot stay online 24/7 talking about Bionano Genomics. It's better to take my time, share a very valuable and informative, content with you guys so that you can learn more about Bionano Genomics instead of just making noises every day and going live stream, for hours, okay? Talking about short squeeze and how the short sellers are going to get burned and so on and so forth. We have to focus on the investment side of Bionano Genomics, okay? Not just the day trading short squeeze size of the stock. So if you have any question, please let me know. I am leaving now. So Victor, have a wonderful day, guys. I remain your boy Dayo. This is Frunkla Investment. Ciao.